Greetings. This morning I'm going to make a video on building a small Python script which becomes a script tool and is also transportable. So this is a useful way to build a tool that you can send to other people. And in this case we're matching the requirements for ASM 540, specifically that the user with a few questions will be able to run the script on their computer as a script tool. I think we're going to start with what it does, and then we're going to get into how we made it. So step one, I've emailed to myself an attachment which is part of the requirement for the class, and we'll open that up and we'll examine how that works. So looking at my attachment in File Manager, I've saved it to my ctemp drive, and so the folder came in the mail, and what's inside the folder, a geodatabase and a short readme that I made in a text editor, but you could use a Word doc. For ASM 540 you certainly want to have some kind of a readme instruction sitting there, and of course the Python script that becomes the script tool. Alright, let's see what that looks like in ArcGIS. I dropped it on my ctemp, as you recall, and so we'll make a connection to that. The name of my script was Python 3, so when I look at it in Arc catalog window, I see the geodatabase, like I would expect. I see the README. I do not see the Python script, but we know it's there because we looked in the File Manager. Just remember that the catalog window does not show you exposed Python scripts. If I open up my geodatabase, I have some layers that we're going to use in the script, maybe a couple extra. I have a toolbox, of course, and down below the toolbox is my script tool. I double-click that to run it. I have a single parameter that my script is asking for. It wants the user to define the input workspace. In other words, where did you put that downloaded package? So my and don't pick a default. Well, the way my script works is you have to pick the geodatabase which I gave you. So that's what's in the README file. Is the basic instructions for this are to set the scratch and working workspaces to the geodatabase we give you. So if I hit OK, then it runs using those parameters. In my case, the names of the input files are recorded inside the script, and so I did not ask for them as parameters, but I certainly could have. So I did not include adding my output layers into the map, but I did create these output layers. Remember, we looked at the geodatabase a second ago. So there we go. Those are soil map clip to watersheds as required by the assignment. So next we'll look at the script itself and see how that worked. The most likely thing you'll encounter as you work your way through this is that when you double click the script, it says like we can't find the script not found, and if that happens, it's probably because your source here doesn't match the name on your computer for that script. So when we built the script tool, we want to store store relative path names so that relative to my geodatabase, my script is located. So let's look at the Python code. I started with a Stack Exchange example, and if you haven't looked at gis.stackexchange.com, I recommend it. It answers questions about ArcGIS, about GIS in general, about Python, about everything else that you can imagine. I'm importing ArcPy and also the operating system so I can deal with the file paths. This allows me to, if I run the script a second time, it will write over the other output, which is what I would want it to do in this case. And so the single parameter that you saw when I ran it, we do a get parameters text on a workspace, and I printed, maybe you saw that, maybe you didn't, as the results went by, I print out the workspace that's used. And actually, as kind of a debug, I printed out twice, which you don't need to do, but I was working my way through this. Um, I have an output workspace, which is, so we take what the user gave us and we store it there so we can use it down below in a minute. I have a feature class that is going to be clipped, and another feature class with multiple polygons that is going to control the clipping. And so for me, I called one poly single and one poly control. You can do however you want. And so the key to making the script iterate is we assign a search cursor to the feature class with the multiple features, because we're going to just work down our rows and we're going to do every single polygon. So I start a counter based on those polygons. And so we have a simple little loop for every row in all of the rows. We build the file name output. So here's the working geodatabase which the user gave us, and we're going to call every single output file outpoly. I could call it Larry if I wanted to, and then it'll append the number of the count on the back. So we have Larry 1, Larry 2, Larry 3, except it starts at 0, so it would be output poly 0 will be the first one for this. And then we do the clip. For the class, you may find that you're doing, depending on how we set the instructions up, you may be doing a clip or a buffer or something else. But the operations happen here, and they increment count to go get the next row. Now, if I were doing this on a really large project, and this was really important to me, I would not want to have them all called output poly. It would be smarter for me to learn how to look at the row and take a watershed name out of the row and append that, and so I have watershed 1, watershed 2, watershed 3. Or I could use feature classes, and then I could come back and do a join when I'm finished, and join in tabular data. So this is pretty simplistic, but it's good for the class we're doing. We have some cleanup down here to make sure we're not having problems with our incrementing, and this was recommended by Stack Exchange, so I'm happy for that. I'll just put that in there. So there's my script. It iterates for every single polygon in the feature class, which is hardwired right here. So this script will always run on this feature class, and that is you could change that yourself to ask that as a parameter if you want, but for the sake of the assignment, we were going to lock these in to make life simpler. So I save that as my Python, and of course when I build a tool, I'm going to do an add script. Sorry, that's probably right off the edge of your screen. Come back over here. Right click, add script. I'm going to give it a name, and remember that the name is actually going to be used in Python. So no spaces, dashes, anything else. That's going to be the name of the Python script, and then a label that ArcMap's going to see. It'd be great if you put your name on that. A short description, and this is the crucial part here. We're storing these relative to that working geodatabase so that the whole package moves in the folder. Oh, I used an underscore. Okay. There you go. So where's my actual file at? ctemp, where we've been working. ctemp, and in the folder that I called Python 3. So there we go. That's the one I recently edited. Now we will have a parameter where, because I'm asking the user for their workspace, the most important question is the data type. What kind of data is it? It is a workspace. So whatever down here. So the script engine will actually test to make sure that what I type in as a user meets the requirements of this data type. So that's a really strong aspect of script tools, is that I can have testing of the inputs without having to write a lot of code. There's nothing down here that I need to change. I could certainly look at those and make sure they look reasonable. So now I have a new script, and it's okay in the label to have a space, but in the actual Python name that got stored on the hard drive, then I wasn't able to have a space or a dash, or I had an underscore, didn't like. So for me to send this to you, then the next step is to take this, basically the folder that encloses that, and turn that into a zip file, which you hopefully have some way of doing. And this one, I just have trouble right now because ArcMap is open and my script is write locked, and so you can't do this with ArcMap open. So that's a good example. I'll leave that in the movie. Anyway, I zip that up and I mail it to my user, and they're able to install it and run it without any trouble. Okay, thank you very much.